Number 15, find the set of all points where the derivative exists for. እዚህ 15ኛው ጥያቄ ውስጥ የተጠየቅነው ምንድነው? የፋንክሽኑ ዴሪቬቲቭ ኤግዚስት የሚያደርግበትን ፖይንት ነው የተጠየቅነው። So I will show you the solution for each of the function. So in a part, our function is f of x is equals to absolute value of sin x. Okay, absolute value of sin x ማለት square root of sin square x ማለት ነው። sin square x ማለት ነው. Because absolute value of x እንዴት ሊገለጽ ይችላል? square root of x square and absolute value of x ብለን መውሰድ እንችላለን. So now let us calculate first the derivative. Okay, derivative exist የሚያደርግበትን point አይደል የተጠየቅነው? So we calculate the derivative of the function. That means what is the derivative of sin square x or absolute value of x? So you can use chain rule or whatever rule that you like. So this means sin square x derivative over 2 times square root of sin square x ማለት ነው, using chain rule. So sin square x and ደግሞ derivative ለመፈለግ you can use product rule. So it becomes 2 times the derivative of sin square x is 2 times sin x cos x over 2 times square root of sin square x ይሆናል ማለት ነው። እዚህ ጋር በደንብ ያዙልኝ። ለምንድነው sin square x derivative 2 times sin x cos x የሚሆነው? የዚህ derivative product rule መጠቀም ትችላላችሁ። Okay, sin x times sin x ን derivate ማድረግ ማለት ነው። Okay, when you apply product rule it becomes 2 times sin x cos x. Okay, so አሁን ወደ ምን መልሳችኋለሁ? እዚህ square root of sin square x ማለት በራሱ ምን ማለት ነው? These two can be eliminated, so it becomes sin x cos x over square root of sin square x ማለት absolute value of sin x ማለት ነው. Okay, absolute value of sin x ማለት ነው. So the derivative of the function becomes the derivative of absolute value of sin x is sin x cos x over absolute value of sin x ይሆናል ማለት ነው። እንግዲህ f derivative exist የሚያደርገው, so f derivative exists whenever absolute value of sin x is different from 0. denominator 0 እንዳይሆን እዚች ጋር ያለችው denominator 0 ከሆነች undefined ይሆናል. So except this case wherever f is existent, f exist ያደርጋል except sin x is 0. So sin x ደግሞ 0 የሚሆነው x ምን ሲሆን ነው? x integral multiple of pi ሲሆን. Okay, where this n is an element of integer. So x should be different from n times pi. Therefore f derivative exists everywhere in the real number except an integral multiple of pi where this n is integer. 1 pi, 2 pi, 3 pi, and the negative pi's, these are not allowed. So this is the answer for A part. With the B part ስንመጣ, in B part the function is greatest integer function. The function is greatest integer function. This greatest integer function f is not, this function is not continuous at an integer. Okay, at any integer. Okay, so it is discontinuous at any integer. Therefore f is not differentiable at any integer n where n is an element of integer. Therefore f derivative exists everywhere. F derivative exists on any real number except any integer, okay, except any integer. Now let's see the C part. In C we have a function f of x is equals to radical x for x between 0 and 1. The function will be radical x for x between 0 and 1, x square elsewhere. So the derivative of this function becomes 1 over radical x derivative means 1 over 2 times radical x. So this happens for x between 0 and 1, and it becomes 2x. The derivative of x squared is 2x, and this happens elsewhere. Okay, so this is the derivative. So we can observe that this here we cannot substitute 0, so f derivative cannot be 0. So f derivative exists everywhere on real number except 0. f derivative 0 ብቻ ነው መሆን የማይችለው. It can be any number. Okay, now the D part. In D the function is f of x is equals to x times cosine of 1 over x for x different from 0, and it becomes 0 whenever x is 0. Okay, this is the function. So its derivative will looks like the derivative of this function becomes the derivative of x times cosine of 1 over x. We take this derivative for x different from 0, and the derivative of 0 is 0 itself. Unfortunately, this works for 0. Okay, so now we have to understand the derivative of this one, x times the derivative of cos times x times cos 1 over x. Okay, you can apply product rule and chain rule for finding this derivative. So this becomes x derivative times cosine of 1 over x plus x times cosine of 1 over x derivative. Okay, so this becomes cos x plus x into minus 1 over x square, applying chain rule on this part, minus 1 over x square times sine of 1 over x. So this becomes there is minus, okay, here it becomes plus, so it becomes cos x plus 1 over x times sine 1 over x. Okay, so this derivative becomes cos x plus 1 over x sine of 1 over x. This works for x different from 0, and 0 for x is equals to 0. So f derivative exists everywhere. Okay, there is no undefined case. Therefore f derivative exists on any real number. It exists everywhere. Number 16 is if f and g are two functions with f of a is 1, f derivative at a is 2, g of a is minus 1, g derivative at a is 3. All this thing is given. So the question is, we are asked to calculate f times g plus f at a. We are asked to calculate this thing and this one. Okay, so here we will write everything. So the question is find f times g plus f derivative at a, and and f over f minus g derivative at a. Okay, so we will see each of them separately. Let us calculate this part first. F times g plus f derivative means f times g derivative plus f derivative. Now we can apply product rule here on this part. Using product rule ምን ይሆናል ማለት ነው? It becomes f derivative times g plus f times g derivative plus we have here f plus f. So this means f times g plus f derivative at a ማለት ምን ይሆናል ማለት ነው? f derivative at a times g at a plus f at a times g derivative at a plus f at a. We have all this thing. እነዚህ ሁሉ ተሰጥተውናል። f derivative at a ስንት ነው? እዚህ ጋር 2. Okay, f derivative is 2 times g derivative at a, I mean g of a is minus 1. So here substitute minus 1 plus f of a is 1, g derivative at a is 3 plus f at a is already given as 1. So ይሄ ምን ይሆናል ማለት ነው? 2 times minus 1 is minus 2 plus 3 plus 1. Okay, f at 1 is 1. So ይሄ ምን ይሆናል ማለት ነው? minus 2 plus 4. The result is 2. Okay, similarly ይሄንንም using the quotient rule የዚህንም ታገኛላችሁ ማለት ነው። Let f be differentiable function such that the derivative of the function is a the power of x. Then find the derivative of f of ln 2x. Okay, የዚህን ዴሪቬቲቭ ለመፈለግ የተሰጠውን ዴሪቬቲቭ ለመፈለግ ምን ማወቅ ብቻ በቂ ነው? ቼን ሩል ማወቅ በቂ ነው። Okay, what is given? It's given that f derivative at x is e the power of x. ይሄን የተሰጠን ምንድነው የተጠየቀው? We are asked to calculate d by dx or the derivative of f of ln 2x. Okay, በጥንቃቄ የዚህን ዴሪቬቲቭ ቼን ሩል በመጠቀም እንሰራለን ማለት ነው። So the derivative of d by dx of f of ln 2x using chain rule, this means f derivative of ln 2x, okay, times the next inner function is ln 2x. We take the derivative of ln 2x, okay, times the derivative of the next inner function ln of 2x. Then the last inner function is 2x derivative. So f derivative at ln of 2x ማለት የሁላችሁ እዚህ ጋር f derivative at x ማለት e the power of x ከሆነ f derivative at ln 2x ማለት ምን ይሆናል ማለት ነው? e the power of ln 2x ይሆናል ማለት ነው times the derivative of this one. This is again another function that requires the chain rule. ይሄ ሌላ ፋንክሽን ነው፣ ቼን ሩል የሚፈልግ ፋንክሽን ነው። so using chain rule ምን ይሆናል? የዚህ part the derivative of this part, let me use different color. The derivative of this part is ln 2x derivative over ln 2x times now the derivative of this part, ln 2x derivative means 2x derivative over 2x times 2x derivative means 2 itself. Now by definition, እዚች ጋር ባለው መሰረት f prime at x ማለት e the power of x ከሆነ this thing becomes, using the concept of logarithm, this becomes ln 2x. Okay, you have to be very careful. This is ln 2x and this part is ln 2x derivative means 2x derivative over 2x, okay, over ln 2x times 2, the derivative of 2x is 2 over 2x times 2. አሁን የሚጣፋ ነገር ካለ ያጣፋ እንሄዳለን። this can be cancelled out, so ምን ይቀረናል? This means 2x derivative is 2 over 2x times 1 over x times 2. So again we have something that can be cancelled out, therefore the result is 2 over x square. ይህን ጥያቄ በጥንቃቄ ካልሰራ ነው ቼን ሩሉን በጥንቃቄ እያንዳንዷን ፓርት ካልሰራን መልሱ ጋር መድረስ አስቸጋሪ ነው። So it requires great attention. So the derivative of the given function is 2 over x square. In number 18, given the function f of x is given, which is x square times absolute value of x. This means x cube for x greater than or equals to 0, or minus x cube for x negative. Okay, so we can replace this x square times absolute value of x by this form, because absolute value of x is either positive x or negative x. So this is our function. We are asked to show that the second derivative of f is continuous at 0 but not differentiable at 0. A function is the function second derivative at 0 continuous መሆኑንና at 0 differentiable አለመሆኑን አሳዩ ነው የሚለው። So this is our function. So its derivative, the derivative of this function becomes, the derivative of x cube is 3x square. This works for x greater than or equals to 0, and minus 3x square for x negative. Okay, if this is the first derivative, the second derivative of this function becomes positive 6x for x greater than or equals to 0, or negative 6x for x negative. Okay, አሁን እዚህ ጋር በደንብ ይውልኝ ሰከንድ ዴሪቬቲቫችንን ነው የምናየው፣ ምክንያቱም እዚህ ጥያቄው ስለ ሰከንድ ዴሪቬቲቭ ስለሆነ። Now let's see how this second derivative becomes continuous. Since the limit of the second derivative of the function as x approaches to 0 from the right, and the limit of second derivative of the function as x approaches to 0 from the left, if you calculate both of this thing, it becomes 0, which is exactly the second derivative at 0. So the second derivative at 0 is continuous at 0, at x is equals to 0 by definition of continuity. So we have shown the first thing. ይህንን አሳይተናል ማለት ነው። it's continuous at 0. How this becomes not differentiable at 0? For example, if we see the third derivative of this function, the third derivative of the given function becomes positive 6 for x greater than or equals to 0, or negative 6 for x less than 0. So if you see the third derivative, we do have the limit of this function as x approaches to 0 from the right and from the left are different. Therefore f second derivative is not differentiable at 0, at x is equals to 0.